Right, so now let's talk a little bit about your general factoring strategy. At this point, or after this point, I'd say, you're not going to usually know or be told what method to use in factoring. But usually there are also certain things about the polynomial you're trying to factor that'll tell you what to do, or at least where to start. So talking about general strategy, let's see how we can figure out, knowing nothing from the beginning, just having the polynomial, what to look for. Okay, first thing that's always easy, check for a GCF. You can pull a GCF out of every term. That is fast, and it'll usually simplify things so you can see what other method you'd want to use on the rest of your polynomial. So always start by trying to find a GCF. Okay, 2. Now, it's the number of terms tells you a lot about what you can do with it. So to me, 4 terms is the most obvious number of terms. Okay. So if we have 4 terms in the polynomial, remember that was the situation where we used grouping. Okay, so if you have 4 terms, grouping is the go-to method. And you can get a long way once you do grouping. Okay, 3 terms. So once we narrow it down, we have 3. That's going to say, all right, there's a whole bunch of different methods we can use. So we might hope that it's the easy cases where we have a perfect square. And if it is, then we can use a formula to do it. We don't have to think about it anymore. Okay, the other option is maybe we use trial and error or the AC method. Okay, so maybe these are kind of 2 different scenarios we can get. But if it's 3 terms, it's going to be one of those 2. It's either use a formula or then go to the AC method. Okay. If it has 2 terms, okay, there's a few things we learned here. So it could be a difference of squares. So look at your variables and see, are the variables just squared? There's 2 things and you have a square variable. Then probably you have a difference of squares and you can use the formula. If it's a minus between the difference. Okay. Now if the variables are cubed, well, then we might think, well, okay, that it's maybe a sum or difference of cubes. We can use that formula. Okay, and then finally, we're getting kind of low here. Let's see. If it is a sum of squares, then it's prime and you're done. Okay. And then once you've gone through and eliminated all these options, so you might go through factor out a GCF, then you see that you have 3 terms, and it's not a perfect square, so you do the AC method. Then you should check that once you factored those out, or did those 2 methods, maybe some of your factors still need to be factored. So a common thing that will happen is you'll go through, factor out a GCF, you see you have 4 terms and you do grouping, and then one of your grouping factors is actually a difference of squares. So once you run through all these options, you want to go back and start at the beginning on each factor and repeat until they're all prime. So that's until they all have a power of, the highest power of x is 1, or the, you may have an x squared in there, but it's in a sum of squares. Okay, so that's the general strategy. I think now we should go through and just work several examples. Okay, so example 1. X squared minus 16. Okay, so first check for greatest common factors. There are no the greatest common factor is 1, so nothing we can pull out. Okay, so we've done step 1. Now we go down, we have 2 terms, and our highest power of x is an x squared. 16 is also a perfect square. It's the square of 4. So it looks like we have a difference of squares. So we can factor that as x plus 4 times x minus 4. Nice. Okay. What about, let's do example 2. So let's say we have 2x squared plus 12x plus 18. Okay, maybe pause and try this out on your own for a second. So, the first thing we might notice is every coefficient is divisible by 2. So that is a GCF. Okay, so let's pull the 2 out. What is left? So we have x squared plus 6x plus 9. All right. So what will we do with that? So this factor here, that has 3 terms. Maybe is it a perfect square, or do we need to use trial and error or AC method? Well, I don't know. I can't necessarily see that it's a perfect square. So maybe let's just go ahead and do trial and error or AC method. Well, so we just have a 1x squared in the beginning. We know that both factors are going to be x plus or minus something. Okay, so then what factors of 9 would add up to 6? Positive 6. So that would have to be 3 and 3, right? Okay, and it turned out it was a perfect square. It's okay if you don't see it at that point. I would go ahead and write it in a more compact form with the power, second power on the x plus 3. And that's our complete factorization. All right, how about, for example, 3. 25x squared plus 9. So maybe pause, think about this one a little bit. Okay, so again, we look at our little algorithm over here. there are no common factors between the two terms other than 1. Okay, then we go down to the option where we have 2 terms. All right, we're dealing with squares. Since x squared is our highest power, 25 is 5 squared, 9 is 3 squared. But we have a plus in the middle. So we're actually doing a sum of squares. We're actually done. That's completely factored. Because it's prime. Easy, right? Okay. Let's do a few more. How about we try, well, this is a good one, 5x cubed minus 45x. So take a minute to think a little bit, strategize. So you might notice first that we do have a GCF here. That's the first thing we should always try to do. So we know we can divide a 5 out of both, and also we get an x out of both terms. So 5x will be our GCF. So we pull that one out. And what would that leave? So if I divide this term by 5x, I'll be left with just an x squared. And then if I divide 5x out of here, that's going to leave negative 9. We factored the GCF. This factor is done. That's generally the GCF. You can't do much with it. But this one, we have a 2-term polynomial. So we need to go down to our 2-term option, and that looks like a difference of squares, right? X squared is perfect square, 9 is 3 squared. So we know that that will factor as x plus 3 times x minus 3. All right. Now we've got it down to every factor with the power of 1, we're done. All right, let's do one more, put it all together. Actually, we'll maybe take the whole space for this. So, example 5. Let's try to factor 2t to the 4th minus 10t cubed minus 2t squared plus 10t. So take a second and think about that one. Okay. So first thing, you notice a GCF for this. I see that I have a t in every term, and also every term is divisible by 2. So I'm going to take a 2t out of there. Okay, so what that'll leave, that's going to leave t cubed minus 5t squared minus t plus 5. So far, so good. We got the GCF out. Now, the thing that's left has 4 terms. So immediately we should think that's grouping, right? That's pretty much the only way we deal with those 4-term polynomials. So let's factor out the groups. I'll group the t cubed minus 5t squared together. And I think we can see that that's a t squared is the biggest factor we can get out. So I'll factor t squared, and that'll leave t minus 5. All right, so I need to end up with t minus 5. I have a negative here. It looks like a negative 1 is the only thing I can get out of both terms. So I'm going to factor that minus 1 times t minus 5. And you can check that that works by multiplying back in minus 1 times t, negative t, minus 1 times minus 5, plus 5. And we shouldn't have the binomial factor matching now, which we do. Okay, so now we would do the second step of grouping, factor out the t minus 5. So we have 2t times t minus 5 times, okay, what's left over? T squared minus 1. Okay, are we done with this? So, what do you notice about one of these factors? 2t is about as simple as it can get. T minus 5 is simple as it can get. Only a power of 1 there. But t squared minus 1, that's a difference of squares. So that's the point where we go back, we look at this factor and we say, okay, which option do we have? Where we have a difference of squares. So t squared minus 1, we now need to factor into t plus 1 times t minus 1. So we have 2t times t minus 5 times t plus 1 times t minus 1. That's our complete factorization.